Okay, hello. Good afternoon. So I'm having too much fun with this. Refactoring and just embracing these patterns and kind of seeing how it all comes together. And I was working a bit last evening and I have another meeting this evening. So I thought, okay, I'm gonna do a little bit more refactoring. So one thing that we talked about last time in with data fetching is it wasn't really about how you approach data fetching. It's more about how that data fetching guarantees references or not. So even though the documentation still explains like these different approaches to data fetching, where one of them is like you just fetch the initial data and then it's the app that drives that state forward. Like your optimistic data changes is applied directly to the data, and you do the mutations in the background on the server. And this gives like this amazing experience of like feeling instant. There's no pending states or anything like that. You rather, if something goes wrong, you will get like a notification that says that we couldn't make that change. You want to try again or whatever. The good thing about this approach as well is that we guarantee consistency in references, because we never replace the data. We just update the data, right? Even the and what's interesting is that even the array or record holding the data will also be consistent. So if it's an array and you have a list component, that list component will only reconcile if you actually add or remove items. And then we have revalidate on mutations, and this is where we don't actually update the data optimistically in the client. We update it on the server, and then we go and fetch all the data again from the server. And in this case, the guarantees are not, references are not guaranteed. Well, it's not even, you can't even use the term guarantee. There's a different term that's about, it's about consistency, but there's a very specific term, like the contract of consistency. I don't know what that term is, but like your references will be replaced every single time you do any change by adding a to-do, removing a to-do, updating a completed state on any to-do. It will always refresh all references. And then you have the subscription-based approach, where by default it's typically just like the previous one, where whenever if you subscribe to the to-dos, it replaces all references on any change. But also with the syncing solutions, there might be a possibility to subscribe to specific changes, which means that you get back into the same potential optimization. Or to put it like this, you'll get into the same position as you were on the first one. You just apply the specific changes that was made, and you keep your references optimal. And why is this important? That's the question. So I added these sections of data references. So when you fetch a list of to-dos, the array of those to-dos and each to-do has a reference. In the world of React, those references matter because it is what memo components use to determine if the component needs to reconcile. The pattern of mapping an array in a component and render a nested memo component is the most common optimization in React. If you use a revalidation approach to data fetching, it means that the to-dos array and each to-do in that array will change reference whenever you make any change to the array or any item in the array. In other words, your to-dos list component and every to-do component will reconcile regardless of any use of memo. Normally, this is no concern, as reconciliation is fast. But if you're displaying a lot of to-dos where each to-do has a complex UI, you risk performance issues. So manual mutation strategy is what best optimizes references and therefore reconciliation. After that, automatic sync, where you subscribe to specific changes in the data, also best optimizes references and therefore reconciliation. Make sure you reflect on how your data fetching affects your data references and the reconciliation of components. It can be a good idea to default to revalidate on mutations, but optimize with custom mutation or change subscription if possible. And then just a deriving thing. And then deriving data references. So I think that really gets to the heart of it. So happy about that. So we were refactoring. And in our state, I think we were kind of done. So our data is all good. We have all our data here. We're subscribing to everything. Family Scrum is happy. So we can actually go in and implement like the groceries view. So what we're also going to do here, I'm going to go to GitHub. And we're going to go to Family Scrum. And we are going to fire up the VS Code. Yeah, and we're going to use this as a reference if we need something. So let's look at groceries and the UI of groceries. So what do we need here? What we need is some input. So we're gonna have what we're gonna call this thing. Yeah, let's just call it input. That's gonna be a string because this is both a filter and adding a new grocery. So it's kind of weird. And then we need the possibility to add a grocery and name. It just has a name. And we also have this cool functionality here, which I added, which what it does is that it plays a video in the background and it actually keeps the screen on on your mobile phone. So when you're shopping, it just keeps the screen on, which is pretty cool. So we need to toggle, and that logic should be on the context, right? Toggle always on. Toggle screen always on. And then we have each item, and the only thing you can really do here is shop it by clicking it. Yeah. So let's look at what we have here. So input starts out as nothing. And what's interesting about this input is that when it changes, there's some logic running. So we can choose how we want to approach that input. So what I think we should do is that we should make that input a getter and setter. I think. Or what do I think? Yeah, this one's a little bit interesting because one way to handle it, like it depends on the experience. Like you can point to groceries in the component, like groceries.input equals whatever. But we want to run some logic when that happens, right? We want to change the groceries that's shown. So we're going to do filtering. And one way to handle that is like get input and set input. And then when we set the input, we also change the filter. So a different way of doing this, I think, is that we're gonna, because there's two things we need to do here. We we have kind of two pieces of state here. We have the state we expose to the component, and then we have some internal state. And that internal state is the actual input state, but also, is there anything else? You know what? I think we're gonna make... Yeah, this one's interesting. I think we're seeing another pattern here. So, okay, so let's just explore this. So this is the state, but we're actually gonna return something else. So this is the input. And we actually don't need... Oh, this is interesting. Wait a minute. Yeah, what's very interesting here is that the only reactive thing in this UI is the input. And of course, the list of to-dos, but that's coming from the data. So that is already reactive. Yes, I want to, like, the way I would actually express this is like, we don't even need a type here. I would just do this. And then I would return, so this should return grocery state. So I would get the input from this dot state, state input. But I will also, when I set new input, no, wait a minute. Am I messing this completely? Yeah, sorry. I'm making this way more complicated than it. Sorry, for some reason in my mind, I was thinking that we manually need to trigger the filter, but of course we don't do that. It's reactive. No. What the hell's... My mind was just completely lost there. So this is simple. Like we have input. Oh. Did we have... Come on. Input. Was there something else? Yeah, it was the add grocery and toggle screen always on. So add grocery, toggle screen always on. Cool. And of course, the only thing we really need to do here is that whenever we can do, yeah, we can use this. Let's see. How does that logic look like? Use app context. Is this where we do it? I think it's inside groceries. Yeah, here it is. Sorted and filtered groceries. Didn't I have some Levenstein stuff here? Yeah, exactly. So, groceries. And then we have all this stuff. Let's see. So we have input there. I don't think we need lowercase. Oh, so it matters. New grocery input. Groceries. Why is this saying any? Oh, interesting. Oh, yeah, sorry. This is coming from a different place now. Sorry about that. And then we need Levenstein. Oh, I haven't installed it. Levenstein. Do I have the types for it? Yarn add fast Levenstein or types. Oh, it actually had the types. That's interesting. Cool. So we're gonna, of course, put this into, let's see, groceries. Oh, we're using the created to now it's date now. Let's add that created, which I believe is date. No, it's that's also interesting because we're using I believe we're using timestamp from Firestore, which I don't like. We should change that. But for now, let's just keep it. And then get created, return grocery data dot created. Cool. And then when we shop, we basically want to say data groceries. Oh, sorry, not data, but context, persistence. Where's groceries? Oh, sorry. Yeah, exactly. So now we're getting into this this thing of some of our persistence is tied to the family, right? And where do we create that? Yeah, we put it into the data, but that means, oh, interesting. How do we want to expose that? Do we want to... Yeah, I think we want to... oh, yeah, how do we want to expose that? I wonder if we want to actually create this and pass it in. Yeah, so let's see. Do we have like family? I don't think we actually have that type. Let's create it. Create family API. Yeah, typing. Firebase persistence API. Oh, no, just Firebase persistence. And I think what we can do is export type family persistence is Firebase persistence. The return type of create family. Return type family persistence. So what we're gonna do is we're gonna rather make it possible to session family, and then we're rather gonna pass the family persistence to data, and then we can also pass family persistence to the other views. But I'm a little bit like, maybe it would be better to, since data is this internal thing anyways. Yeah, you know what? We're gonna change it back. I changed my mind. So data, we're actually, let's see, we got the session here. We have the family persistent. So what we're gonna do is, well, the thing I don't like is that family persistence has like methods to go and grab different things. Well, this data is just data, right? It's not, it doesn't have any functionality. That's kind of the point of this data thing. Okay, now we're moving back to what I had, sorry. Oh, it doesn't even need context. Okay, and then, oh, no, I broke it. Family persistence equals create family API session family ID, and then we're just going to pass family persistence in there. And then we can also pass family persistence into create groceries, for example. So let's see what it actually needs. So it definitely needs data. And to make sure we follow the we want to have family scrum here, because we always want to, following the pattern, we always want to be able to back reference up the tree. So we're going to attach family scrum there. The question is, what else do we actually need here? Yeah, so I think that this is also a question, like, when do you actually like break this into an object? Like, how many arguments do you want to take there? Family persistence. But this is the thing, like, this is the thing about classes as well. You explicitly pass dependencies down, right? Which can feel like a hassle at times, but it is a strong contract. It's the same with the props passing. You're creating a strong contract. We could do like something like dependency injection, but again, the state tree won't be that nested. Like, we're not going to go down even more levels here. So yeah, I think that's fine. And then when we shop, we're going to point to family persistent groceries, delete grocery data ID. So this is the pattern of encapsulating each grocery data with like a specific API designed for the groceries. I was saying that classes are no different in handling dependencies. Yeah, blasphemy. Yeah, I've been taken as a person who hate classes. I think classes are, it's a nice construct. It is. Okay, so, and again, we're using Firebase with syncing here. So we're just going to delete it. It will immediately show in the UI, which is nice. And then we have add grocery, which is going to be family persistence groceries add. Is it add? Oh, is it create? No. Add? No. Oh, interesting. Yeah, because it's different how we add something here. We have something called set. And what we do is we actually... Yeah, this is interesting. Because we say family persistence groceries create ID. Yeah, I think I learned a lot from you, Adam. Or no, I would never say that. I'm not gonna blow steam up your, what's it called? Up your ass or whatever. But you reminded me of like I think you've been quite consistent in how you build your apps over time. Well, I've been going like crazy exploring a lot of different concepts. But at the end of the day, like these fundamental concepts of like having a state tree, just fetch the data you need, just change the data you need, just have a way to organize it. And classes is and classes they help with that structure. Yeah, maybe you should if only GIFs had audio, right? You could just loop it. Let's see, name would be this dot input. And I wonder, like, what do I actually do here when I create a new grocery? And grocery. Yeah. Okay, so I actually created that, but that's fine. We can do that for now. But don't we have like create timestamp? By the way, I'm gonna destructure this a little bit. Let's see, cons groceries, family persistence groceries. Groceries API. Let's say groceries API. Groceries API. And then I think I actually have... Oh, but that's on the... Yeah, I don't super like this having this like wrap. Like I like having this wrap family persistence, but that it's split up from the other stuff. Because we have something called server timestamp, but that comes from the other one. Yeah, so it's going to be interesting to see when we actually build up the UI for this. One thing is, or build up the components. One thing is the strong contract with the props, right? But also with routing, as you mentioned, like having this like custom view implementation, it's very, very simple. I just have one component that does a switch on the current view. And then I just render that component. That's the only thing it does. And then as you kind of click the different things, I'm just pushing views to the stack, which is going to trigger like the root component that switches on the current view. And then I can call back, which pops the current view, and it triggers the top component and flips out the view. So it's very simple, but it's going to be fun to show it. But what was I going to do? Yeah, because we have this like create server timestamp, but that comes from not the family persistence. That comes from the context. Yeah, okay, but let's pass in all the things. Context, family scrum, data, family persistence. It just needs all of that stuff. And then we're gonna do this, and then context is context. And then we're gonna context data, family persistence, and family scrum. We need all of that stuff. Let's shove this into a type. Let's just call it, I don't know, props, params. Cool. And then we have, let's destructure a little bit. So we're gonna have const persistence equals context dot persistence. Persistence. Create server timestamp. This is the thing I should really use here. But yeah, what we could also do here is like, because all of these collections, all of this data, it's not just ID, it also has created and modified. So we could have put that behind, like instead of set, it will be add, and then we would manually add the ID and created and modified, and kind of remove that from the type of add. Yeah, I'm struggling with when you have a few levels deep and dealing with the... Oh, the FI, you mean the revalidate? Oh, no, you mean... oh, sorry. You mean like keeping the view after an F5. That's funny, though. Like calling revalidating data an F5, because it literally kind of is. Yeah, but actually this app doesn't keep that. It doesn't keep the view state after a refresh. And the reason is that whenever you open the app, you want to start from the start. I'm not persisting that state. If I were to persist that state, I would use a router. Yeah. So yeah, sorry to break the tension. So that's kind of also why I did do a custom implementation, is because I want the app to start from the start every time you open it. Anyway, so we're gonna set it, and then we're gonna set input to nothing. We did that, right? Yeah, look at that. Look, this is a great example. This is the old add grocery code, which has like a direct Firebase thing. And for some reason, I'm also, yeah, I'm not sure why I also update the value of groceries, because Firebase does that quite immediate. But even without that, well, yeah, I guess you could argue, like we also have the catch here. I could add that. But still, well, it's maybe not that different. It's instead of Firebase set doc, we're not passing the groceries collection, we're not passing it on create ID. Yeah. Let's see. So we need current input. So what I'm doing here is like, if it fails for some reason, setting it. I'm just catching it and resetting the input. Very quick. I don't have any notification system here, so I would typically show a notification here if it failed. But at least it's like some handling of error. And I guess we could make this async, and we could rather try. Catch. I guess this is more proper modern code. That looks nice. That's adding a grocery, and then we have toggle screen always on. Do I have that here? Where is that? Awake. Oh, look at me. Okay, so we're just gonna copy all of this, and then we're gonna implement this in a context instead. Video update callback. Oh yeah, sorry. Here's the video. Okay, let's copy that, and we're gonna create a new. Wait, didn't I change this to context? So let's add awake, and we're gonna call this create awake. And yeah, and now we're kind of in this position again where like with the camera, like the camera actually uses reactive state, and we talked about like that's it, was primarily intentional for the state tree itself, but there's nothing wrong with making something reactive elsewhere if it simplifies. So the reason I'm making it as part of the context is just because it uses like a video element. So look at this. None of this insane reconciliation stuff. So we can say video ref, we can say call it ref. Let's call it video. Video. So this can be, yeah, now we're doing this refactoring thing again. Let's see. And it's gonna have, well, I guess the only state it's really gonna have is, oh yeah, good point on the, that's what happens when you refactor groceries. Oh yeah, exactly. Yeah, and let's not do any catch here because I'm not really doing anything. Yeah, exactly. Good point. Good point. Good point. Should have a notification system. That would be nice. Anyways, awake. There's really only one. Yeah. Current on, like, let's make a little state machine of this, like explicit states. Well, I guess it's off. And then let's see, export type awake would be current off or on, and then we just have toggle. That's really all it is. And then we have toggle. It's interesting how I'm using the exact same pattern for I'm using the exact same pattern for the context as I'm doing for the state tree. The only difference between like building a state tree and building this context is that a state tree is just more nested. But it's the exact same patterns I'm applying. So I can make a context thing be reactive and can use a state machine and whatever. And the reason I'm not like doing the full-on state machine here is because it can only flip the current state and it will always have a toggle. So there's no reason to put it into its own thing. So I just check if this.current off. Yeah, whatever. Play. Oh, fudge. Yeah, I didn't think about that. We have to get the HTML element in here. But I don't think we actually need to get it from the DOM, like from React. We can just document create it and append it. What should we call it? Play video. We can just keep a reference in here for that. Video would be document create element video. Play stop. So function play would be underneath here. And let's see, what's the logic here? So when it's, yeah, I guess video, where do we have the actual video? Where's the video? Oh yeah, I guess the video is in the other one. I think actually video.source is like MP4. Is that how I do it? Oh, video TS. Oh, look at that. Yeah, I guess we don't need to do this even now. Const MP4. Yeah, and I think we just set it. So this is the video element. We put an MP4 base64 encoded video. And when we play, we basically just, let's see, we do video play, we add an event listener. Oh, this is interesting. Let's see. Video, add event listener, video. Yeah, this one's interesting because we need to manage this listener. But I would do this differently, I think. I would rather add this. Yeah, I don't think we need this. The video is what keeps the screen alive. So when you play a video, it just makes the screen stay on. But it plays in the background. You don't actually see it. The only thing you see in the UI is like the light bulb turning on. But yeah, the screen will actually stay awake. So it's just a looping tiny video. So let's see. We're going to add event listener here. And then we have the video callback. And this should always just be here, right? It's just listening to that thing. Yeah, so this is the looping mechanism. So we don't need, so we can just say video, yeah, video play, video pause. Look at how much simpler this got. We don't need this stuff even. So this would be video play, video pause. Yeah, and then of course flip the current on. Off. That's it. That's pretty readable. And then we're going to shove this on the context. Awake, create awake. Yeah. And then in our groceries, toggle context dot. Yeah, and what's interesting about this, maybe, you know what we could do? We could just put it there. Because it really is just a reactive object now. So we could awake, and we can just say context awake. Just put it there. So grocery state has not this thing, but awake is awake. Wait, awake. Yeah, so that should just work. Curious why it's complaining though. Oh, interesting. Oh, wait, that's interesting. Oh, sorry. Yeah, it's I think maybe part of the pattern should be to Oh, you're kidding. Seriously? Oh yeah, I think I know what. It can be a bit tricky to know where to put the type. So you could have put it here, the return type, but then you see you get some iffy behavior here. Or you can put it here, which is guaranteed to give you the correct thing, but it could also be const awake like this, but then you get an error again. So putting the type on the reactive thing is the right thing to do. Interesting. Okay, so now we're gonna clean up this thing. So what's kind of sad about this is that you can't like reference a getter. So we're kind of forced to do oh, what did I do? Wait, did I change something or did I just I just changed file. So what we can rather do here, the cool thing is that like I'm making all these references now, right? But I can still just, to refactor this, I can still just do return filter groceries. I can just call it. And I'm just going to put filter groceries down here. And then I'll just paste the code. And the only thing I need to do is to const groceries. Oh, oh, that's fine. Why are you complaining? Oh, sorry. Yeah. Let's call it grocery state. There's a lot of groceries here. Well, I'm still returning grocery item. Yeah, that's probably because of it's a getter. Yeah, but the point is, like, I could just move it down there. I didn't have to, like, fix a bunch of stuff. Though it does say something about, like, preferring to use this or just always do this. By the way, I think I'm gonna start calling this state. Because it really is the state. It's kind of like the state branch you're returning. Whatever. Yeah, so like I think this is a good reason for not using this. It just makes it easier to refactor and clean things up. Because if you point to this one, you can always just move logic down to separate. So we're gonna do that now. Like add grocery function, async function, add grocery. Oh, look at me. You can just move it down and you don't really have to change anything. Oh, sorry. We didn't have name there. Yeah, so this is super clean. Okay, let's get going. I guess that's groceries. What's the next thing we need to tackle? Checklists. Okay. Let's see, checklists. Yeah, so I don't think checklists are much. It's just to-dos with checklist. But let's see what that is. It's coming from app context. To-dos with checklist. Oh, okay. We can add that. That's the only thing we really need to do. So we have another data. I have so many files open. Let's see. Family Scrum. Or sorry, data. Oh. Where did that come from? So we're gonna add, what did I call it? To-dos with checklist. Did I add anything to that? Or does it automatically handle it? Because to make that correct, yeah. By the way, I'm gonna do this rename. I'm gonna make that a thing. Yeah, I'm just reflecting on like what we want this to be. It's basically array. Is there like I'm gonna ask. Is there a simple way in TypeScript to make an optional property not optional? Something like pick foo. Only making optional properties not optional anymore. I love this reasoning thing. Yeah, this sucks. But can't I... Yeah, because the problem is you have to omit it first, and then you have to add it again. Yeah, it's a little bit sucky. But this is unrelated to anything. Where should I put that? Yeah, let's just make it... They should have that in TypeScript. So this would be... Oh my god, I'm about to sneeze. Oh my god. Okay, so this just makes the actual checklist type correct. So what we're gonna do is get this with checklist, and we're gonna return state of check. Oh, to dos. Yeah, and I guess we have to do the... Yeah, I could omit it from like to do DTO and then add it back in. But yeah, I guess I could do that to avoid having the thing to do. And checklist item is a little bit like, yeah, it looks like shit regardless. I'm not sure if this looks any better. Yeah, I'm gonna keep this one, Adam. Yeah, and then we can data state to use with checklist. Oh, interesting. So it doesn't understand that. Yeah. Oh, I thought that was a new thing in TypeScript. Which version of TypeScript am I using? I thought it had now the understanding of... Huh, that's interesting. But maybe it's because of the Boolean. Does it understand that? No. It's not able to infer that like this filtered list is actually this... Oh, yeah, but I think I'm using the checklist in other places. So it's not like just... There's not like two different arrays of to-dos that use differently. I think when I just look at the to-dos, I give it like, do I have a checklist or not in this to-do, even if it's not in the actual checklists view. But yeah, because that would indeed be simpler. But this kind of sucks. I thought the filter was... I saw this video. I saw this video about TypeScript. Maybe it's coming in the next version. Like that filter is becoming much better. It's able to infer this kind of thing. So for now, we just have to do... Oh, come on. Are you joking? So we have to do this and this? Come on. TypeScript. Okay, I'm gonna complain on the version here. Which version am I using? Oh, how do I choose the version of TypeScript? Isn't that supposed to be down here somewhere? No, weird. Whatever. I believe that I saw a video on this, but anyways, let's just do that for now. Well, it's kind of sucky. And why did this one work? Yeah. But there is a version TypeScript. Select TypeScript version 5.7.3. I guess that's the latest one. Yeah, interesting. I wonder what's up with this thing that makes it so... It's probably some type complexity with this type. Yeah, and what we're doing here is that we're like changing the... Like one thing is if we're... Like if we have an array of numbers and strings, and then we do like is number, then the array becomes only numbers, right? But now we're changing a type, like an actual object. Yeah, maybe it is a setting. But you don't have to type getters unless you're pointing to state or you're actually using like this. That's also a thing. So yeah, I think so. Yeah, but this is a weird one. But why the filter doesn't work? Yeah, I have no idea. And I think like the reason you have to explicit return type is because you're pointing to something on the same object. So it's a self-reference. So if I was pointing to something outside, it wouldn't like happen. So that there's two things here. It's the self-reference, and then it's like changing the type of to do, right? We're not changing what types are available in the array. We're changing the type of what's in the array, and I don't think filter does that. Yeah, so I can't remember. I asked ChatGPT about this. Union types. And I can't remember typing this as undefined. I did ask it. It has to do with. It made sense when I read it. It's because it's trying to determine the type of like the actual return type here without this having been evaluated yet. So the way I understand TypeScript is that it evaluates types that's kind of the same way as a runtime, right? So it's evaluating this type and you're pointing to state, but that hasn't been evaluated yet. Just like the runtime, right? So all of this, but it's not correct to say runtime because this is evaluated at runtime when this is already created. But from like a static perspective, this hasn't been evaluated by TypeScript yet when you statically analyze this code. And that makes sense to me. Yeah, it works with, and it does work with this. So if I were to use this instead, so it's the this reference that does it. You see now it has that thing, but this is something else, I think. Yeah, this is messy. Kind of annoying. Yeah, it is kind of annoying. Anyways, let's not get stuck on it. Yeah, classes. Like typing should work better with classes. It's where it all originates from. Let's see. What were we doing? Yeah, to-dos with checklist. This is all we need for that view. To-dos with checklist. So this is the thing, right? We're not like creating an explicit checklist state branch. Like we've chosen to use data here because from a state perspective, the data is just everywhere. So it's not like we're looking at the UI and making the state tree exactly like the UI. No, state and UIs are different. UIs derives from state. And then we're getting into interesting things. This one. Oh, yeah. This is complex stuff. Let's see if I can find some code for it. So we have this plan next week. Yeah, and then I have like different contexts. So this is like here you're seeing, this is one of the first versions of Impact where we kind of fuse, we're fusing state management with the UI. Categorize to-dos. Yeah, so we're, let's see, categorized. This is a lot of stuff. Like a lot of logic goes into. Yeah, so it's basically, I'm calling it categorized to-dos. So I think we're just gonna. Yeah, this is interesting. Like, yeah, I think this is a point for reflection. It's like, okay, we have these two derived lists. One being the checklists, Yeah, the non thing makes sense, but not that to do is any. Yeah, I agree. Yeah, the view thing, it didn't happen. But another thing I completely forgot here is that we're now gonna derive. We're not gonna derive into we're gonna derive into like a view specific state here. So actually, I do think we're gonna put checklists as a state thing here, and we're also gonna put the week plan next, like the plan next week thing as a state thing, because the reason is the functionality. Like I've completely decoupled state and functionality here, but now we have a chance to bring that together and make it like super clean components. So we're gonna do that. So I'm gonna move this stuff from here, and let's just remove this, and let's create checklists. Create checklists. So type checklist state would be checklists. Well, it's not gonna be unsubscribe. Where did you take that from? With required to do DTO on the checklist. Yes, and then we're gonna bring in context here. I think maybe at least data. We're gonna bring in data. I guess that's all we need. And then we do this. Oh, to do with checklist. Let's call it that. And this will be data to do's. Yeah, I wonder now what happens, because now we're not self-referencing anymore. You see this? Not self-referencing. Oh, sorry. I guess I need to do checklist state here. Yeah, so now it's just a filter that's not working. But you see, now it works fine because it's not self-referencing the state. But yeah, still need, can I just override it now? No. It's funny, that filter thing. Okay, whatever. Yeah, but what we want to do, okay, we're gonna do the checklist thing and then I have to stop. But something that's interesting, I don't think we only have checklists here, I think. Do we? I can't remember. Maybe we do. Okay, maybe we do. Yeah, whatever. So with checklists, we're gonna, yeah, this is old stuff. Anyways, so we're gonna introduce some state around each item here to reflect what we want to do with these checklists. So we're gonna create a new thing called checklist state, which would be, what do we need? What do we need? Yeah, I guess we need the ID. I'm not sure if we even need the ID. Yeah. Let's see. Well, first of all, we want to be able to archive the thing. Well, checklist item state. Or should we call it checklists? Let's call it checklists. What else do we want to do? So you could argue that this collapse thing, this could be a UI state. And that's like, that really is UI state, in my opinion, because it really has nothing to do. So as opposed to an input, you could say input is also UI state, but I disagree with that, because you want to sync that UI state into your state management so you can manage the text in the input. Just like when we added the grocery, I wanted to empty out the input, for example. I want to control that text. But when it comes to like a collapsible thing, it becomes much more very UI specific. So maybe you could argue that when you, I don't know. Yeah, I don't know. I guess like if it suddenly wasn't isolated anymore, maybe you wanted to like toggle all and close all. And then you might have, and if you were to do that, then you would have to keep track of the IDs of the ones that was open. But then you get into the complexity of, oh, what if someone adds a new item? That should also be open by default now. And then you have to be able to do that, you have to detect if you add a new one and then add it to the array. Like it can get like surprisingly complex. So if you just manage that within your state management, then it's fine. So we're just for fun, we're gonna do that. Toggle to-dos, or is it toggle items? Toggle items. And then we have the actual items, I guess. Checklist item. Oh, sorry, of course. So that's an actual checklist. Oh, wait a minute. Checklist state. Sorry. It's checklist. Like we have checklists. So it's each of them is a checklist. Sorry. Where we have items. Oh, this is very interesting. Like, and then you have like each item can be toggled. And it can be removed actually. Oh my. So what we can do here is so what we could do, we could derive each item into its own state as well. And then we would toggle each state, or you could remove each, toggle each item, or you could toggle, remove each item. It's interesting. Like, 'cause when we go down this path of like exploring how to wrap data in state, it's like, how far do you go with it? Because it would be much simpler to just do like a toggle item and then you pass in the index, right? And remove item and pass in the index. But at the same time, it's like, well, why not just put it on the item? Okay, we're gonna go all the way with this. So type checklist item state. So that would be, it has a name. What else did it have? Yeah, and completed. Oh, interesting. Yeah, I guess we can do checklist item because we still want to expose everything from it. But we also want to toggle it and we want to be able to remove it. It's very interesting. Oops. Okay, so how would we actually derive this? So first of all, yeah, what's kind of nice now is that we can actually map over this and we should be able to, yeah, I wonder now, like if I do to do here now, let's just write it inline first and then we'll change it later. Yeah, exactly. Yeah, this is kind of annoying. So what I think we're going to do instead is we're going to say checklist state, and we're going to say with required to do DTO, and we're going to make checklist required here. Yeah. Cool. And then what we're going to do is derive. So we're going to return the checklist state. And again, we're just gonna inline it for now, and then we'll see what happens. So what we need here is archive, toggle items, and then we're gonna have items, and we're gonna derive to do dot checklist, and we're gonna inline this one as well, just for now, but we're gonna move this into a cleaner thing where we return get completed, return item completed. We're gonna, what was it? Title? What is it? Oh, sorry. Checklist item state. Wait, why is it giving this weird typing? Why isn't it giving me the... That's weird. That is certainly weird. But what was it? Checklist item had title completed and completed by user. I don't think the completed by user is actually shown in the UI. So let's do title return item. And then it was, oh, so annoying. Toggle remove. Wait, you're still not happy? Oh. Oh yeah, sorry. We're not gonna have the completed. Ah, this is a complicated type. This is kind of annoying. So what we can do here, like since I know that so another approach here is that like now we're trying to merge it, right? We're trying to merge the functionality with the actual data properties, but you can also like just have a getter for a data and just return the data. And then you add the functionality next to it. But anyways, maybe that's why the typing was weird, because it was a union or something. What was it called? Completed by user ID. Yeah, and then like the type, yeah, it's a fucking union. Fucking unions. Being so correct and being so horrible to work with. But what I know we can do here is like we can do item like this. And the reason we can do this is because we're revalidating the to-dos. So there won't be any like, yeah, and that's also very interesting. Like if I were to do like a mutation approach on this, so for example, if I manually handle the mutation, so when you toggle an item here, I would just go in and change the completed state, right, of that actual checklist item. But if it's checked, it should also have who checked it. But if it's not checked, it should not show who checked it. So that means I have to like add and delete that property as I'm checking it. I can't replace the item itself, because that's the whole point, is that I just want to flip the completed thing to keep the reference for the item itself. Fucking unions. Yeah, it's very interesting. So it is like, it's much simpler to like do like get data and then return item here, for example. But then it's not as protected, because then you can still go in and you can like change the item. I actually think it's also possible. No, you can't change it. No. Yeah, but I can click it, right? Can I? I click here. Yeah, look at that. Yeah. Yeah, this one's up for reflection as well. So when you wrap data, do you really want to merge functionality with the data? I kind of want to do that. Well, in this case, the data is a union. But I think this is also, I remember this having unions in data. Like it's not broadly supported. Like even, was it OpenAPI? I recently worked with that, and they don't actually support unions. I think they're trying to now, but historically they haven't supported it. And I know working with backend folks, they don't like not passing fields. I prefer having like a proper null reference to a field, both on like request and response. So that if you omit a field, it means don't do anything with it, while setting explicit null means like nullify this field, remove it, or like nullify it in the database. There is no like no field in a database or traditional databases. It's like nullified. But Firebase actually supports like not having the field there. But again, if I want to update the item, How does this item actually look in the database? Yeah, I think in Firebase it is allowed to have, like, some records can have the field there, and some records might not have the field there. But it's a struggle for me to have completed by user ID null and then have completed as a separate field, because they're so tied together, right? You could also change completed to be not be a true or false, but it's the actual, either it has the ID of a user or it has null, right? And then you kind of solve that union issue. Yeah. You know what? I need to stop streaming, but this is a very interesting thing. I think this is more like bad, like this is a bad data piece of data, because it's a union and it's not like, it doesn't lend itself well to, yeah, but at the same time, yeah, this is super annoying. This is super annoying. I want to protect it. I want to protect the completed state and the title. Well, I guess maybe the right way. I never actually tried to put getters around the union. So I guess what you could do here is, like, what would be runtime correct here is like return item completed, or it's undefined, right? Oh, yeah, sorry. No. So that's actually wrong. Type string or undefined is not it's not assignable to type string. Yeah. Because it's very interesting, because checklist item completed by a user ID is typed to string, but it's you know what we're gonna do? We're just gonna do this. Title string completed boolean, because this is what we want to expose, right? Yeah, sorry, it's as simple as that. Where am I missing a return here? Type undefined is not assignable to type checklist item. What's that? Yeah, it's easier to use a state machine to resolve unions. Definitely is. And I would intuitively go to that. like it was if I was building something new, but it's like a union in a data field or in a data entity. It's weird. But yeah, so let's just clean this up. So what we're gonna do is we're gonna create a checklist. Well, let's do this. Function create checklist. Yeah, so yeah, exactly. So we need to yeah, let's just call it to do with checklist. So we have to say as to do with checklist because of the filter thing. Oh, can't I do this? Oh, do I have to do... How do I do this? No. Oh, sorry. I think I can do... Can I do... No, I can't do that. Filter. Is that what it's gonna be? No, I can't do that. Ah! Sorry. How the fuck do I do that? Do I really have to say to-dos with checklist? And then return to-dos with checklist. Yeah, interesting. Wow, it's very, very weird that maybe we can ask ChatGPT. I thought TypeScript supported type inference in filter now, but I have this type. Maybe we can let's see, what was it? To do DTO. And I am filtering on getting to-dos with checklists, doing to-dos filter to do boolean to do dot checklists. But it is not able to... I feel very confident that it's about narrowing the type of the array, not narrowing the item in the array or the type inside the array. But the result is still the same to do type. I'm very confident about that because that would make a lot of sense. Built-in inference won't narrow the type when you use simply truthy check like boolean. To let actually know. Oh. To let you need to write an explicit type card. Oh, so I can rather do that. Yeah. Yeah, exactly. Yeah, it just doesn't understand it. Yeah, but that's good because that's much cleaner. Where are we? Checklists. So to do is to do with, look at that. And then we can return this. This is how it should be done. Look at that, beautiful. I forgot about type cards. This is kind of nice. Cool. And then we have to do with checklist. And then we're gonna go over this and we're gonna create checklist item. Nice. All right. So it is very clean, I would say. I think the only like, so what's the practical situation here? Like you're sitting with a fellow engineer talking about, maybe you have this mock in front of you. You're talking about this UI and you're discussing like, okay, what state do I need? What functionality do I need? And you can talk about, okay, we need to show the name or the description of the to-do. We need to be able to archive it. We need to show the number of completed items in the checklist. We want to add a new, yeah, this is quite complicated. We also need this stuff. Wow, that looks like shit. So we want to add that thing. We want to remove it. Talk about all this stuff. And you basically creating a list of all the functionality. And the point is that when the UI engineer actually implements this, they just implement the actual UI for it. They don't have to manage all this state. So this is actually even more complex. So, okay, let's try to finish this. So we don't only have data here, we also have the family persistence, and the family and that nice thing now is that I don't have to like do a public or private like in a class Adam. I can just import it and I can point to it wherever I want, in the constructor, in my methods. It's just there. To-dos, delete, to-do.id. And then toggle items would be family persistence, to-dos, update, to-do ID, completed. Oh, doesn't it have... Oh, was this... Oh, sorry, this was a UI state, sorry. We need to add that. So here we can do family. Oh, I think this is like updates. We don't like the actual checklist items are stored on the actual like oh yeah, we need a reference to the to-do here as well, because we need to know the ID of the because we're not toggling the item isn't its own entity in the database. It's just a field on a to-do. So to be able to toggle it, we actually have to update all the checklist items on that to-do. So we need to do ID here, which requires us to do to-do. Oh, sorry, not here. Sorry. That wasn't what I create checklist item. Oh, now I'm getting confused. Wait. Did I put that in front of the other one? No. To do ID string. What the hell did I do? Oh, sorry. Checklist item. My bad. And then Oh, this is also interesting. Like, because now to be able to, yeah, this isn't an entity in and of itself. So I think I'm not going to do like create checklist item. And the reason is because it's just an array on the to do. So when you're toggling it, you're not toggling an actual checklist item in the database. You're basically just flipping the, you're just changing an array. And then you're passing in the whole array to Firebase as an update of the to-do. So it becomes like, or we have to also pass like the index here, which I guess is fine. Yeah, maybe it is fine. Okay. Yeah, and let's pass it to do instead. Yeah, you know what? We're gonna pass in the index instead. So what we can do is like we can say const item. Oh, sorry. To do with checklist. Like it really feels a little bit overkill, all of this stuff, but oh, sorry. But we're doing it to like really hammer down on protecting the data. And then we would do to do ID. And then what we can do here is like we can just say checklist index. Yeah, and I guess we will actually have to replace it because yeah. Item.completed. So what I'm wondering, the reason I'm stopping is because I'm wondering about like how to do the mutation. Since it's a union, this is a very special kind of thing. It's like it's a union and it's an array attached to a to do that might or might not be there. It's like the the most horrible thing to describe in code. I've not made it easy for myself. Because what I think I would really do here is I would rather say checklist is do the checklist and then like slice it up to the index. Like do a sort of and then like item completed. Well, this wouldn't be true. Yeah, I don't like this. This is horrible. And it doesn't understand. Oh yeah, it doesn't understand that it needs. Oh, and the union doesn't even work. What the hell? This is still... Come on. This is silly. This is super silly. You know what? I think I'm just going to change that. It's like a horrible way to store that information. And as a family, we haven't done anything anyway, so I can just change how we deal with this. I want to rather make completed either null or it's the ID of the user. I think. Yeah, I don't like this at all. So, but again, it's like, it's why you don't want to expose it to, like if I was working on the UI, I would be so upset about this. Completed by user ID. Let's just put it in there. And we also need, now we should make this a param. Because what we also need here is family scrum. Oh, sorry. So type params equals family scrum. Oh, look at me. So what's interesting now is that when I point to family scrum, and again, I just love that I can point to it down here. I can point to session. So that's our first use of accessing parent state. And we should have family scrum here as well, family scrum. And shove that in on the thingy here. But yeah, this was this is and we're not even like half done here. Like, look at all this complexity. You can toggle adding a new one, and you can add that one, and so on and so on. There's a lot of complexity here. Yeah, I have to stop streaming. But this was certainly interesting. I think we're gonna keep this for now. It's just, this is more like data complexity, that we kind of have this array where the items in that array is a union. Like, it doesn't make it easy to like update that in a simple way. But at least we can hide that complexity here. I think this is correct. I think we're replacing the item now. Okay, and then remove, that will be something similar. Where we just do this, I think. What was slice? Returns a copy of the section for both the end index of the, this is exclusive of the element. Yeah, exactly. So we're exclusive of the element, and then the beginning of, if start is on the, but is this including? Yes, I think this should be +1 actually. Yeah, I think so. Okay, so that was remove. And then toggle items, this is like a UI state. And we would need to, I think we would need to like properly implement this, like being able to toggle adding a to-do or not, all of that stuff. But the nice thing is that, like, this UI being relatively complex, you can like one person can sit and work on the actual functionality and state of the thing, and then the other person can just build up the component only thinking about how things should look. And they can just hard code the states, right? So instead of like implementing the state management of toggling, adding a new item here, they can just say hard code true in an if, right? And then implement that. And they can just use these fake checks to handle the dynamic nature. And then when the state management is done, they can just use it, and then it should just work, just like a backend engineer says that an API endpoint is done, and it just works, right? Okay, thanks for following along. We're gonna get through this, but it's gonna take a little bit of time. Cool, bye.